This is a review for your transformations and characteristics of quadratics test. Our first question says write the equation in standard form. If you want to write in standard form, remember you have to have negative x plus 2 times x plus 2 minus 1, and then x times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4, still negative 1 on the end. I'm going to go ahead and distribute my negative and combine my like terms. So I'll have negative x squared, 2x plus 2x is 4x, but it's the opposite sign, so minus 4x. Minus 4, subtract 1 on the end. When I combine my like terms at the end, I have y is equal to negative x squared minus 4x minus 5. Find the vertex, and is this point a minimum or a maximum? I'm going to find the vertex from vertex form right here, so I know it's the opposite of my inside, negative 2, and then my outside number is my k, negative 1. Because my a value is a negative, I know that it's going to open down, so it's going to be a maximum value. The axis of symmetry is related to that h coordinate on my vertex, so x is equal to negative 2. And the y-intercept, I'm going to choose the y-intercept from standard form, so I know it is at negative 5, so 0, negative 5. So I'm going to go ahead and plot all these points, negative 2, negative 1, 0, negative 5. I know it has an axis of symmetry at negative 2. The point symmetric. So this y-intercept is 2 units away from my axis of symmetry. So if I go 2 more units on the other side, this point right here is my point symmetric at negative 4, negative 5. F of negative 3. To find f of negative 3, I'm going to plug negative 3 in for x. So negative 3 plus 2 squared minus 1. Negative 3 plus 2 is a negative 1. So I'm going to have the opposite of negative 1 squared minus 1. Negative 1 squared is positive 1, so negative 1 minus 1, which is a negative 2. So that is f of negative 3 is at negative 2. I know it also has a point that is symmetric to it, so if I go right over here, I've got a point at negative 1, negative 1. And I'm going to list all of my points right here, so my furthest to the left is negative 4, negative 5. Then I had a point at negative 3, negative 2, negative 2, negative 1, negative 1, negative 2, and 0, negative 5. So there's my table, and here is my graph. Alright, next problem. Given f of x is equal to 2x squared plus 4x minus 1. Find the vertex, and is this point a minimum or a maximum? I'm going to find my axis of symmetry first because I know it is x is equal to opposite of b over 2a. I'm going to label these a, b, and c. So a is 2, b is 4, and c is negative 1. So opposite of 4 is negative 4 divided by 2 times a, which is 2. Negative 4 divided by 4 is negative 1. So x is equal to negative 1. That is my axis of symmetry. That is also the x-coordinate of my vertex. If I want to find the y-coordinate, I need to substitute negative 1 in for x. So 2 times negative 1 squared plus 4 times negative 1 minus 1. Negative 1 squared is 1. 1 times 2 is 2. 4 times negative 1 is a negative 4 minus 1. 2 minus 4 is negative 2, minus 1 is negative 3. So negative 1, negative 3 is my vertex. My a value here is positive, so I know that this point is my graph opens up, and this will be a minimum. So negative 1, negative 3 is my vertex. I have an axis of symmetry at negative 1. My y-intercept is my c value, so it is at 0, negative 1. My point symmetric, well, this is 1 unit away, so 1 unit away right here will be at negative 3, negative 1. Find f of 3. So to find f of 3, I would substitute 3 in for x. So 2 times 3 squared plus 4 times 3 minus 1. 3 squared is 9. 9 times 2 is 18. 4 times 3 is 12 minus 1. 18 plus 12 is 30, minus 1 is 29. So I know this is going to go through 329. That's not on my graph. So I've got the points negative 3, negative 1, negative, I apologize, that's not negative 3, negative 1, that's negative 2, negative 1. Negative 2, negative 1, negative 1, negative 3, 0, negative 1. I see that this value is 2, so I know that it goes over 1 and up 2 on both sides. It would also go over 2 and up 8. And the way I'm getting that 8 is normally on my parent function, if I go 2 over from the vertex, it goes up 4. But because of this stretch of 2, I'm doubling that value. So over 2 and up 8. That points at 1, 1, 5, and negative 3, 5. And there is the graph of this quadratic. Write this equation in vertex form. Well, my a is going to be the same value, so it's still going to be 2. So y is equal to 2, x minus a negative 1, or x plus 1 squared, then my k minus 3. Alright, next one, I have y is equal to negative 1 over 8, x plus 5 squared minus 2. Alright, and ask what is my vertex? So my vertex right here is at negative 5, negative 2. Ask what is the value of p? So I'm looking at my parabolas, and that y is equal to 1 over 4p x minus h squared plus k. Okay, so my value of p, so 1 over 4p is equal to negative 1 over 8. Then I cross multiply, get 8 is equal to negative 4p, divide by negative 4, p is equal to negative 2. Alright, so then my focus, well I know my focus is 2 units away. I'm going to graph my vertex at negative 5, negative 2. I know that my vertex, this is a y equals, so it's going to open up or down. My p is negative, so it's going to open down. And p is 2 units below this. So my focus is going to be right here at negative 5, negative 4. My directrix is going to be 2 units above my vertex. So if I go 2 units above it, it's right here at y equals 0. The axis of symmetry, the line that's going to split it, would be right here, and that's at x equals negative 5. Alright, so I'm well on my way to graphing it. If I wanted some points to go on either side, I know that I'm going to be plugging them into this right here, which isn't very user-friendly. If I put in a 3, I'm going to have 3 plus 5, which will be 8. 8 squared, so I'm plugging in a 3. And the reason I got a 3 is I'm looking for what can I plug in right here to give me a multiple of 8. I could choose 3. Another easy one to pick would be a negative 1, because 3 plus 5 is 8, negative 1 plus 5 is 4. I'm going to probably do both of those just to give you an example. So negative 1 over 8 times, if I put in a 3, I'd have 8 squared minus 2. 8 squared is 64. 64 times negative 1/8 is a negative 8. Negative 8 minus 2 is a negative 10. So I'd have the point at 3, negative 10. If I'd chosen negative 1, I'd have f of negative 1 is equal to negative 1 over 8. Negative 1 plus 5 is 4 squared minus 2. 4 squared is 16. 16 times negative 1/8 is a negative 2. Minus 2 is a negative 4. So at negative 1, I'd go through negative 4. So it looks something like this. Alright, next one, squeezed in at the very bottom, says given the focus is at negative 4, 0, and the directrix is at x equals 0, write an equation for the parabola. Alright, so if we're looking at this, the focus is at negative 4, 0. The directrix is at positive 4. Halfway between those is the origin, so this one's going to be centered at the origin. It's going to open to the left, so x is going to be equal to, and 1 over 4p y squared. My p-value is going to be this -4. So x is equal to 1 over 4 times -4 y squared, or 1 over -16 y squared. That is the equation for that. Alright, given the graph, what is the vertex? So our vertex right here is at -5, -8. Has there been a reflection? No, it still opens up. Is there a stretch or compression? Well, if I look over, I go over 1 and up 2. That's twice what I normally do, so it's a stretch of 2. What is the equation in vertex form? So my stretch of 2, so y is equal to 2. If this had been a reflection, it'd be a negative. X minus a -5, or plus 5 squared minus 8. What is the y-intercept? So the y-intercept occurs when x is 0. So y is equal to 2 times 0 plus 5 squared minus 8. So 2 times 5 squared minus 8. 5 squared is 25. 25 times 2 is 50. 50 minus 8 is 42. So the y-intercept is going to be at 0, 42. The axis of symmetry is this vertical line that splits our parabola in half, so that's going to be at x is equal to -5. My point symmetric, so if 0, 42 is 5 units away here, then my point symmetric is going to be another 5 units away at -10, 42. The domain, this graph is going to go infinitely in both directions, so the domain would be from -infinity to infinity. The range, the bottom of my graph is at -8, and then the top keeps going, so -8 to infinity. And then true, false. If false, correct the statement. The axis of symmetry always goes through the vertex. This is true. A quadratic can only have 2 x-intercepts. Okay, it can have a maximum of 2 x-intercepts, but it could not cross the x-axis at all, in which case it would have 0, or it could touch it at one spot and have 1. So a quadratic can have 0, 1, or 2 x-intercepts. The vertex of a quadratic can be a maximum point, a minimum point, or neither. This is kind of a bad question because I didn't put in a quadratic function. If it's a quadratic function, it can have a maximum and minimum. If it's just a quadratic equation, that's when it opens it left or right. It could be neither. So I'm going to have no answer there because I phrased that poorly. A quadratic must have a y-intercept. This is true. We're going to say that these are all quadratic functions because it's going to have to cross that y-intercept eventually. True. The axis of symmetry is always y is equal to a number. Okay, well, that would be true if the axis of symmetry, if we're looking at a quadratic equation that is this way, but if it opens up or down, if it's a quadratic function, it's going to be x equals a number.